consider innovation in the project. When identifying our problems, we first research marine science careers, brainstorm project ideas, one of our favorite ideas, and narrowed it down to our problem. Our problem was scientists needed earlier and more up-to-date data to understand red tide and harmful algae. Our solution was Waterbender. Waterbender is an autonomous underwater vehicle that helps scientists predict when red tide will be next. When designing our plan, we first broke down the project into separate parts, researched these parts, researched what others had done, created our initial AUV design, talked to experts about our design, and iterated with their advice. In our discovery phase, we all did research for our project. Our topics fell into 3 categories: red tide, AUVs, and optimal detection of pigment. And these are just some of our sources.
Red tide is a harmful algae bloom that can the Gulf of Mexico and the southern Atlantic Ocean. As you can see, it endangers marine life and people and annually causes about 100 manatee deaths according to Florida Fish and Wildlife, which is upsetting because there's only about 6,000 left. Red tide is a single-cell algae called Corona brevis and has a red pigment called paraffin, which absorbs light at 480 nanometers. That's important because we use spectrometry and we use that wavelength of light to detect how much red tide is in the sea. Also, population explosions, which we call blooms, they can spread by wind and current.
These satellite images show how quickly red tide can spread from the coast to on the ocean by wind and current. Waterbender will detect red tide while it's spreading. The problem with the way scientists currently monitor red tide are bad because water samples from boats are expensive. Stationary detector systems are stationary and satellites only detect the dense blooms that already are there.
The concept for our project is that Waterbender, a drift AUV that moves passively with the current, will be launched into an existing bloom of red tide. It will drift with the algae as the current spreads it, measure the amount of red tide algae in the water, and send the data to scientists so they know when the red tide will start to bloom again.
While creating Waterbender, we knew there was a system needed to be able to have missions that could last weeks, detect red tide, send data, have GPS, and get unstuck. We did research on these 3 AUVs. We looked at propulsion systems, communications, and the duration of missions.
We worked as a team to design and research Waterbender. We used shared Google Docs to take notes. Samples of those Google Docs are in the binders we gave you. Some of the technology we integrated into Waterbender was advanced, so we worked together to wrap our heads around it. Waterbender will have an antenna to contact the satellite, a battery on tracks to control the pitch in the water, a control computer, scientific instruments, an oil reservoir to tip the antenna above the water, and an emergency retractable propeller. Waterbender's battery shifts forwards and backwards on a track to change its pitch in the water so that the wind's effect sails in the water current. This uses very little power, so missions can last up to 30 to 90 days.
This shows how Waterbender measures the amount of red tide pigment in the water. A sample of ocean water is drawn in with a peristaltic pump, which moves the water by squeezing the flexible sample hoses. The sample is filtered to remove everything larger than a single-cell organism. Then the cells in the sample are popped in an ultrasonic device to release the red pigment within the sample. From there, the sample flows into the sample chamber of the spectrometer, where the amount of pigment is measured. Then the sample is shot back out into the ocean.
Waterbender uses spectrometry to measure the amount of red tide pigment in the sample. A light source sends a beam of light of wavelength 480 nanometers through fiber optic cables to the sample. That's the wavelength of light that red tide pigment absorbs. The spectrometer measures how much of the light was absorbed by the sample and sends that data to a tiny computer, where it's stored over time. Later, Waterbender will surface the antenna and send the data to scientists by satellite phone.
We shared our project with 3 experts and incorporated their feedback as we iterated the Waterbender's design. Dr. Derek Gunther is a senior staff scientist at Ocean Optics, which makes very small spectrometers. He helped us understand spectrometry in general and gave us tips to how to incorporate one to our AUV. Sam Paramore works at User Ultrasonics, which makes cell disruptors. He told us that we didn't need a system to clean the sonic heater. James Carpenter is an electrical hobbyist and who goes to Carl Sandburg High School. He helped us understand a type of propeller called a rim-driven thruster that is ideal for an emergency propeller. Waterbender will help biologists who study red tide better than other ways because it will detect blooms early and faster, and it will save manpower and money. Thanks for listening.
Awesome.
Can you be a little bit
Yep.
Yes. Nice, thank you. All right, nice job. First question is, in your mind, how this project is in line with ocean exploration?
I think because red tide is harmful to the ocean environment, and like we showed on the slide, it can cause a lot of danger to animals and just the environment around us, because what it does, it sucks out the oxygen in the water. So when, like marine biologists and explorers, when they come to, research animals or samples in the water, it gets hard because the water is filled with the toxins.
Also, people who research this don't have a good way of doing it.
What are some current solutions out there that you might have researched, come across in your research?
Well, we talk about the satellites, the boats in the stationary detection systems.
And also other abilities, as Grayson mentioned, that's how we took inspiration.
Yeah, but
But they didn't work as well.
yeah,
I really like your filtration system that you went through. Have you guys built a prototype based on that, or is that maybe the next step if you had more time? Okay.
Were you able to, do any research on potential cost?
Yes. So we researched that it would be somewhere between 100,000 and 150,000.
Is that based on similar systems or?
Yeah, that's for sure.
So in your minds, what do you think is innovative about the solution that's different from the satellite images and the other things out there?
It saves more time and money and manpower because the other ways they are either too slow or the red tide blooms already happened before they detect it.
Yeah, because it doesn't need to be like manned or monitored, it just does its own thing, it can save manpower and time. And we can, because you can see because it drifts with the red tide, you can see where the red tide is going and when it could potentially bloom and where.
So you had mentioned your process earlier in presentation. This is a very specific problem solution. How did you find it?
So, I do have a little bit of background in Florida because my grandparents do live down there. So whenever I would go into the ocean, there would be red tide blooms here and there. And I kind of learned on it on my own, and I realized it was a problem. So when we were figuring out our problem, I kind of brought that to the table.
Yeah, and another idea we had was researching AUVs, and we couldn't really decide if we wanted to do red tide or AUVs, so we sort of combined them into one project.
We've heard that term once or twice today, so it's kind of nice to hear about red tide.
Yeah.
Nice. What, are you all returning this season?
The girls are new, but yeah, this is our second year.
Okay. How did you approach the project differently this year versus last year?
Last year, it was our first year, so we really didn't have a good idea of what we were doing. So this year, because last year we didn't think we would do good, which didn't end up happening. But this year we assumed we were going to do well again, so we actually planned it out a lot more carefully.
Yeah, we sort of didn't really know how much research other teams were putting in. We assumed it was just like a side project, and then the robot game was the main thing. But this year we sort of realized that we need to put as much effort into this as we can.
Did you guys have fun?
Yes.
Yeah.
Yeah.
All right, we are right at time. I hope things are going well out there. Thank you for bringing this really interesting project to us, and thanks everyone for bearing the snow and getting here.